Hello everyone. So welcome to this session. And if you see this particular video is coming after so many days gap. So actually I would be honest with you. I could not make a lot of videos because of Lumino. As you all are aware that I have changed the name of this channel to Lumino, and I have to address this personally to all of you that yes, Lumino is something that I'm working upon, and it is a base where students are going to learn academically, and it's going to be a lot of benefits for them, right? So I'm not here to talk much about Lumino. You can go to the website and see what we actually do there. So right now, what I have decided is that I will be concentrating on IB, MYP, and DP level a lot, right? So I'm starting the video series where I'm going to solve some of the past papers of MYP. And this paper that you're seeing, this question that you're seeing is question number 2 for May 2016 paper, a very old paper. But I like this question a lot, and that's the reason why I'm bringing this question to you. Okay. And of course, it's a criterion A. Now, how am I going to discuss this thing with you is in the form of, so I'm just not going to give the answer. I'm actually also going to give the idea what a marking scheme expects from this. So that's why this video is going to be a little different compared to the previous videos which I was making. Right. And if you want the question, if you want the PDF of this particular question paper, it is given in the description. I want you to do that question. Take some time, pause this video, do this question, and come back and see how I am doing this question. Right? So this is your pausing time. You can pause. And if you're done with that, let's continue here. Now you can see here a robotic probe is sent to space to collect data from 3 of the 4 inner planets. We know that 4 inner planets are Mercury, Mars, Venus, and of course I have Earth also. Okay. While passing close to each planet, the probe drops a test object from the height of 100 meters. The shape of the object ensures that any frictional forces are negligible over the fall distance. Fly with the probe to collect the data. Click the name of the planet to measure the time taken for the subject to fall. Now, this is a clickable format. Okay, this particular question was a clickable format, so I'll take you. So, Mars, you see, for every planet, even for Earth, right? For every planet, the 100-meter was kept constant. The 100-meter was kept constant, and the time was measured for each case for the probe to fall down from 100 meters. And you have the time here, you have the distance here, right? So by now you must be getting an idea of what types of questions are going to ask, and let us look into each question from that. Right. Now, first question asks you, using the data you collected above, calculate the acceleration due to gravity on Mercury and Mars. You may wish to use the formula sheet. Now, of course, formula sheet is given to you. You have to remember that. So first, let us do for Mercury. Let me go and see Mercury. Time taken was 7.4. So what's given for me? Time. The time is given for me, and that's 7.4. I'll make it a little more smaller. It's very small. Time given is 7.4 seconds. Right? What else do I have? The distance I have. The distance covered is equal to 100 meter. The distance covered is 100 meter here, right? Isn't it? There you go. You see Mercury 7.4. Distance covered is 100 meter. Okay. Now what formula shall I use? They are asking me to calculate the acceleration due to gravity. Okay. Now I can clearly tell you that if you look at the 3 equations of motion, you can't use the first equation because you need to know the final velocity. You can't use a third equation because you need the final velocity, and I do not know the final velocity in both the cases. So the only formula that's going to be my savior is going to be S is equal to UT plus half AT square. Now the best part here, let me tell you students, the best part here is that U is 0 because my object is beginning. When it is beginning to fall, the velocity of the object is obviously going to be 0, the initial velocity. And you have to also understand that the acceleration is nothing but the acceleration due to gravity that we are trying to find. So now let us do for Mercury. So for Mercury, I will go 100 meter, right? I'll go 100 meter, half, then G of Mercury I'm trying to find, and T square, that's going to be 7.4 square, right? That's going to be 7.4 square. Now, if you solve this, students, if you are going to solve this, oh, 1 second, my screen has gone. Yeah, if you are trying to solve this, you will get the acceleration value around 3.7 meter per second square. 3.7 meter per second square. So my given value, my formula that is required, I plug in all the values, I got my answer here. Okay. Now I do the same thing for Mars, right? Now for Mars, what are the details that I have? Now, since I have showed you Mercury, I'm sure that even Mars you can do easily. What is the detail I have for Mars? 7.3 seconds, right? So for Mars, my time, a small change, that's all. It's almost the same, but the small change is that time is equal to, it's very small. Yeah, time is equal to 7.3 seconds. And my distance obviously is going to be equal to 100 meter, right? Simple. I have given a detailed value and my formula is going to be same for it, right? My formula is going to remain same. And here, of course, that's a square, I did not mention. So if you apply the same formula, what will you get? It's very simple, 3.8. See, now I'm not doing it here because my whole idea here is to make you understand how to look at a problem and how to solve a problem. Now, for calculation, you have calculator. Obviously, I'm very well know that most of you already know how to use calculator, so I'm not worried about it. So you plug in the formula, plug in the details, and you're going to get the answer. Now, students, very important thing, if you do not write the unit, you are going to lose mark. If you do not write the unit, you are obviously going to lose mark in this case. So you have to be very careful. Do not forget the unit, right? Okay, fine. Now, after getting the answer, so remember, this is totally this 3-mark question. So how it became 3 mark? 1 mark for G value of Mercury, 1 mark for G value of Mars, and 1 mark if you are writing the units correctly. Now understood how the examiner is going to see? 1 mark for G Mercury, 1 mark for G Mars, and 1 mark for unit. So if you get these 3 things right, you are going to get 3 marks completely, right? Okay, now the scientists receiving the data on Earth know that gravitational field strength G is proportional to the planet's density. Now this is something that is given to you. They're not asking you anything out of it, but they're told that gravitational field strength G is proportional to the density and the radius of the planet. The radius of the Mercury is about 2/3 of the radius of the Mars. Now they have given you something. The radius of Mercury is 2/3 of the radius of the Mars. Mercury is smaller, right? So what are they asking here? So what is the question? The question is, explain why Mars and Mercury have this almost same value of G if Mars has much larger radius. Now, the answer comes from this equation. They have given us the equation. Let us use this. So G is proportional to the density and the radius. Now what's given to me is that they almost have the same G value. Think carefully. They almost have the same G value, but Mercury is having 2/3 of Mars radius. So radius of small m is equal to 2/3 of capital radius of capital M. Small m, capital M. Small m, Mercury, capital M, Mars. This is the way how I am representing here. Okay. Now, if they are having same G value, now listen carefully. If they are having same G value, that means this 2/3 has to be get cancelled by something, right? If I'm substituting the value of 2/3 here, that means this has to be cancelled out by 3/2. So 2/3 into 3/2 is going to be 1. So that clearly means my Mercury, okay, my Mercury's density is 3/2 the times of Mars density. So Mercury is more denser. Mercury is more denser. So this gives me an idea. So this is a logic that you can apply here. Okay. So this gives you an idea that the density of Mars is 3/2 the density of 3/2 the density of density of Mercury, small m, is equal to 3/2 times the density of Mars, capital M, density of Mars. Now, when this logic is prevalent, when you multiply these both, you are going to get equal. You see, rho small m into rho rm, rho small rm. Okay, so what you are going to get? So 3/2 rho of capital M into 2/3 r capital M. So 3/2, 2/3 gets cancelled. So this is equal to rho mass is equal to Mars is equal to radius of Mars is equal to rho of Mercury into radius of Mercury. That's how they both have same G value. That's how they both have same G value. So this is 2 mark. Okay. So let me tell you, your marking scheme might not require you to show all this calculation, but you need to bring in this logic reference stating that the Mercury is more denser than Mars. That's very important here. Okay. Now, moving to the next part. Next question asks you, next, the space probe visits 2 of Jupiter's moon, Io and Ganymede. The experiment is repeated and again a test object is dropped from a height of 100 meters. The gravitational field strength of Io is this much and the gravitational field of Ganymede is this much. The test object has a mass of 20 kg. Use the information from the formula sheet to calculate the gravitational potential energy of the test object before it is dropped over Io. Okay. Now they're asking you the gravitational potential energy, and the formula for gravitational potential energy is mgh. Now they're asking you what is the gravitational potential energy before the object is dropped from the Io. So I have the mass, very straightforwardly they have given the mass. I have the G 1.8 and I have the height also, which is 100. So when I plug all these values, 3600 joules. 3600 joules or 3.6 kilojoules, whichever suits you. You can write that. This is for 3 marks. Equation 1 mark, right? Getting the current answer 1 mark, either any one of this, and unit 1 mark. Multiple times I have seen students not writing the unit, and that's a mistake. Please do not miss writing the unit. If you just do the calculation and you get the number, it's not the end. Write the unit, very much important. Okay. Then moving forward to part D. All the test objects of gravitational potential energy transforms to kinetic energy before hitting the surface. The test object travels faster before hitting the surface of Io than hitting the surface of Ganymede. Why does the test object falls faster while hitting IO. The reason why it becomes faster is because they clearly told us mgh turns into kinetic energy. Kinetic energy tells you how fast the object is while falling, right? So I can say that greater the mgh, greater the kinetic energy, more faster it is. Now if you see clearly, your io is going to have a greater mgh value because it has greater g value. See, 20 kilogram and 100 meter remains same, but for io you see the g value is greater, so mgh value for io is going to be greater, and hence when io is having greater mgh value, the greater kinetic energy it will have. And it's, you don't have to think about it, it's given the question, it's given the question. See, ep gets converted into kinetic energy, and you should know that kinetic energy decides how fast the object is. So this is how you bring in the answer, right? So what does your marking scheme says for three? It's for 3 marks. The marking scheme says that G on dynamite is smaller. Sorry, the G on dynamite is smaller. That's why gravitational potential energy in dynamite is going to be smaller. Okay, and all the potential energy is turning into kinetic energy. Second point, and keeping other all quantities same. Third point, you have to say that that is the reason why IO will have a greater speed, right? So this is the question. So yeah, I hope you understood this question. Now I will be solving these type of question every week so that you get a hang of how to write the answer well and how to understand the concept well. Okay, so with this, so I will end my video with this, and please do subscribe for this channel. I will be creating content on MYP. I will be creating content on DP. I'll be creating content on universities also if you see and students struggle. So if you are a student, I'm sure that you would like to subscribe Lumiknow. Right. So with that, I'll close my video, and we will see in the next week. Bye, students.